Hello everyone, welcome to today's class. Let's start with our topic for today, that's limit. Okay, so let's first understand what is the overall requirement of this chapter and what is the meaning of this word limit. Suppose I give you one expression, x square minus 4 upon x minus 2, and I ask you to calculate, like this is your function, no? Sorry, and I ask you to calculate at x equal to 2 what's your f of x. So what you'll do, you'll put the value like 2 square minus 4 upon 2 minus 2. It is coming 0 by 0. We cannot say it's 0, it's an indeterminate form. Okay, it cannot be defined, so we don't know that what is this 0 by 0. So in order to get the idea that not exactly at x equal to 2, but what if this function, see, first of all, this function will not be definitely directly defined at 2, because the moment it becomes x becomes 2, the denominator becomes 0 and it is not allowed as such. So what if I want to know that if x is approaching 2, I'm not saying it is exactly 2, it is approaching 2, means 2.00001, it is getting close to that, x equal to 2, then what will be the value of this function? That is the purpose of limit. Okay, so we cannot calculate if x is approaching 2 what will be the value directly using this algebraic method. We need a new concept known as limits. Okay, that was the requirement part. Now let's understand from graphical point of view. Okay, this is your function fx. Okay, and let's say this is your graph. Okay, it's like this. Okay. A, let's call this point as A. Okay, or let's get some value, let's say 2. Okay, this is 2 and the value here is 5 and the value here is 3. Okay, now there are two words that I'll define. First is LHL, known as left hand limit. Okay, what does that mean? It means that if you approach this function from the left side, means you start tracing it from here and you keep approaching at this point at x equal to 2. If we are approaching from the left, what is the value attained by this function? In that scenario, the value attained is 5. Okay, that means limit, it will, first of all, it is represented by limit x tends to 2 minus. 2 minus means just before 2, just before 2 this function is approaching the value 5. Okay, let's say here just before 2 this is attaining 5. Similarly, RHL, limit x tends to 2, function is equal to 5. Similarly, RHL is right hand limit. Okay, so what does that mean? If you approach this same function from the right towards the left, from right towards left, and you approach this value of x as 2, then the function is getting close to which value? It is getting close to the value 3. Okay, so I'll say limit x tends to 2 plus. 2 plus means just after 2, something after 2, just after 2. Okay, the value the function is trying to attain is 3. Okay, now you'll say that I have drawn graph like this, that's why it is coming 2 different values. Yes, of course, in order to understand what's left hand and what's right hand limit of the same function fx, I've drawn like this. Sometimes they may be equal, sometimes they may not be equal. Now the point is, if left hand limit and right hand limit, they are equal, then limit of function exist. Means it's not like that limit will be defined for every single value of x for every function. Sometimes for some particular value of x, limit will not be defined. Okay, if only LHL and RHL are equal, then only we'll say the limit exists. Okay, so in this scenario, clearly LHL is not equal to RHL. So therefore the conclusion is that limit will say directly x tends to 2, means if the function is approaching 2, if the x is approaching 2, the function, we cannot be sure whether it will attain 5 or whether it will attain the value 3, because it depends from where you are approaching the function, from the left side or from the right side. Limit x tends to 2 does not exist. Okay, and this is the condition for limit to exist for any value. LHL and RHL, they should be equal. Okay, now something we have done. Let me now illustrate with few examples to help you understand this concept more. The starting part is slightly typical, I'll say, slightly, but have patience in this chapter for the first part, because the upcoming part will be pretty much standard. There will be certain ideas that will be directly applicable, but this one, to understand this one, it will require some more patience. Okay, look at this question. Your function fx is 1 plus x square. Okay. If you have x greater than 0, less than equal to 1, and it is 2 minus x if x is greater than 1. You have to find limit x tends to 1 fx. Now first of all, in order to find the value of the limit, first LHL and RHL should be equal. So let's find LHL, left hand limit, that's limit x tends to, he's saying find the limit at 1. So we'll say x tends to 1 minus. Now 1 minus means we'll put the value of x as something very less than, just less than 1. Okay, just less than 1. Now how can we do that? First, okay, in order to do that, first of all we have to select the function. If we are calculating LHL, means x is less than 1. For x less than 1, this should be your function. That means this should be your function. So the function is 1 plus x square. Okay. Now, in order to solve these kinds of question, you have to put, first of all, change it to limit h tends to 0. So I'll give you one conversion formula as such if you want. You can use your common sense also. If suppose question is limit x tends to a minus fx, it becomes limit h tends to 0 f of a minus h. Means replace the value of a as a minus h in x. Similarly, limit x tends to a plus fx can be converted to limit h tends to 0. It will become a plus h. Okay, I'll explain this. So we'll convert this limit h tends to 0. Replace x by, this time a is 1 na, so replace x by 1 minus h. Now h is very small, so 1 minus h will be definitely less than 1, and that's what we were calculating now. 1 minus means just less than 1. So this is the way to represent. And in order to solve these kinds of limit, right now you don't have the idea how to solve the limits, so just put the value of h as 0. Okay, so if I put the value of h as 0, 1 minus 0 whole square, that becomes 1 plus 1, that becomes 2. You might feel, then what was the overall purpose to write limit? You'll see. Once we are done with this first section of it, you'll see the purpose of writing limits. Okay. This is how you calculate. if you are calculating left hand limit, 1 minus, you have to, for limit, if you are calculating for 1 minus, replace x with 1 minus h. If you are calculating for 1 plus, replace x with 1 plus h. 2 minus, if suppose limit is x tends to 2 minus, so replace x by 2 minus h. 2 plus, replace it by 2 plus h. And h is tending to 0, replace h with 0. Only in some particular scenario you will not be able to put h equal to 0. Right now you can directly use this. Let's calculate RHL. Now first of all, we'll say RHL will be right hand limit, so we'll put limit x tends to 1 plus. Okay, right. LHL is you can use this. This itself is your LHL, this itself is your RHL. Okay. So for if you want to calculate RHL, you have to calculate limit x tends to 1 plus. Okay. Now you have to select the function. 1 plus means more than 1, just more than 1. If x is more than 1, we have to select this as a function. That means this time 2 minus x will be your function. And now replace x with limit h tends to 0. Replace x with 1 plus h. 1 plus means 1 plus h. And put h as 0 again. 2 minus 1 plus 0. It is again coming 1. It's coming 1. Now clearly you can see the conclusion that LHL is not equal to RHL. So we'll say that the limit x tends to 1 for this given function doesn't exist. Okay. Put box on this, how to calculate LHL and RHL for any value. LHL means limit x tends to a minus, RHL means limit x tends to a plus. Let's see one more. Same kind of example I'll take. Your function is 5x minus 4 for x 0 to 1, and for greater than 1 but less than 2, function is 4x cube minus x. Okay. Again the question is saying find limit x tends to 1 fx. So we cannot find directly limit in this scenario because the function depends whether x is less than 1 or more than 1. So we'll have to calculate LHL, means limit x tends to 1 minus. Okay, and then we'll have to calculate RHL, which is limit x tends to 1 plus. We have to select the function. For 1 minus, limit x tends to 1 minus means just less than 1. For less than 1, this is the value for x less than 1, so that means this has to be the function. So for first one, LHL limit is x tends to 1 minus, function is 5x minus 4. For the second one, 1 plus means more than 1. More than 1, here it is written more than 1, x is more than 1, so that means this has to be your function, 4x cube minus x. Okay, now change it in h tends to 0, limit h tends to 0, replace x with 1 minus h. Here also replace x with, this time, 1 plus h whole cube minus 1 plus h, and then put h as 0. So 5, 1 minus 0 minus 4, that gives you 1. This becomes 4 1 cube minus 1, so that becomes 3. Sorry, 3 was here also, so this becomes 3. 4 minus 3 is 1. So yes, this time LHL and RHL, they are equal. That means limit exists, so your limit x tends to 1, your function is the same value that you saw, that's 1. Okay. All right, this gives you some idea. Now this is one type of question. Let's see another type in this. Another time is when the question will say that the function's limit already exists. Okay, this time we are finding the limit. The type that we'll discuss now will have limit already existing. Let's see the question. This time your function is again 4x minus 5 if x is less than equal to 2, and x minus lambda if x is x is greater than 2. Okay, and he's saying that the limit, this is the part of the question, so limit x tends to 2 fx exists. He hasn't given you the value, but he's saying that the limit does exist. Find lambda. Find this lambda. Okay, in order for limit to exist, the concept is LHL should be equal to RHL. So limit x tends to 2 na, so LHL will be x tends to 2 minus, and the function will be, for x 2 minus means less than 2, for less than 2 function is this 4x minus 5. Selecting function is more important here. Similarly, right hand limit means x tends to 2 plus just after 2. Okay, just more than 2. Now for more than 2, this is the function x minus lambda. Okay, and now you have to convert this in h. Limit h tends to 0, replace x by 2 minus h. Here also limit h tends to 0, replace x by 2 plus h, and then put h as 0. So 4 bracket 2 minus 0 minus 5 is equal to 2 plus 0 minus lambda. So 8 minus 5, 3 is equal to 2 minus lambda. That gives you lambda as minus 1. Okay, for lambda equal to minus 1, the limit of this function will exist. Okay, all right, one more question of this time, so you get comfortable now. Fx, this time I'll make it slightly more complicated. A plus bx comma x less than 1. Whenever they can write comma, semicolon, or if they can write, the meaning you have to understand. For x less than 1, this is the function that you have to consider. It is 4 for x okay, equal to 1 and b minus ax for x greater than 1. Is saying limit x tends to 1 fx is f of 1. Find a and b. Okay. Okay. First of all, what is this f of 1 meaning? The meaning of this is fx at x equal to 1. So if x is 1, what's your fx? 4. That means this value is 4. Okay. Then comes he's saying the limit is something. In order for limit to be something, it has to exist first, and if it is existing, we'll use the same concept that LHL should be equal to RHL. So limit x tends to 1 minus, this will be limit x tends to 1 plus. We have to select the function. For x being limit x tends to 1 minus, the function we have to select is will be, for x 1 minus means less than 1, less than 1 is here. So for this function will be a plus bx. So we'll say a plus bx is the function. for 1 plus. Okay, so for 1 plus means more than 1, more than 1 means x greater than 1, so that will be the function. Okay, so b minus ax. Then same steps, replace it first with h tends to 0 and replace x by 1 minus h. Here limit h tends to 0, replace x with 1 plus h. Put h as 0 now, so it is coming a plus b, this is coming b minus a. b cancels, you will get 2a equal to 0, a is equal to 0. You got the value of a as 0 just by solving this. Okay. And now how do you get b? See, the question says na, that this limit will be equal to f of 1. Let's use that. So limit x tends to 1, fx is f of 1. Okay, this is the first part we got. So it has to be 4. Now limit x tends to 1 will be which value? You can take a plus b or you can take b minus a, because this is the value we solved. Okay, because LHL RHL exists, so both values will be your limit and they must be equal. So for that a has to be 0, so I can take anything now. So it will be, let's say it is a plus b and it is equal to 4. So already I know that a is 0, so that gives you b as 4. Even if you took, suppose you took the limit to be b minus a, okay, and it is equal to 4, still if you put a as 0, you'll still get the b equal to 4. Okay, so it doesn't matter which one you take, whether you take LHL as your limit or RHL equal to as your limit, because both of them effectively are equal and is the value of this limit x tends to 1 of this function. Okay, all right, this was slightly typical, I can understand. What you do is be patient with this, go through this short lecture that I just discussed, this specific part again over this, understand how do you calculate left hand limit, how do you calculate right hand limit, okay, and more importantly how to find these lambdas and a and b, because these are the kind of questions that are usually preferred in the exams. Okay, all right, now let's get to the real part of limits, where you learn how to solve limits. How to solve limits. Now this time we'll not be talking about left hand limit, right hand limit, we'll directly calculate limit for any given function. Okay, means the questions that will be given, LHL and RHL, they are equal. That means limit are existing, it's just that you have to find those limits. Okay, when do we have to do LHL, RHL, this thing? Whenever you have a function broken like this, for less than 1 it is something, for more than 1 it is something, then only you do this, otherwise you can directly calculate limits. Okay, I'll start with the first method known as direct substitution, and this is what we have been doing here. Direct substitution means just put down the value. Okay, like if the limit was h tends to 0, I told you to put the value of h as 0, na? So same thing, the name suggests what the name is. Let's see the question. Suppose you have a limit x tends to 1 and your function is let's say x square plus 3x plus 5, something like that. How do you calculate this? X tends to 1, just directly replace x with 1 square plus 3 into 1 plus 5. You got the value, 5 plus 3, 8 plus 1, 9. That's it. That is direct substitution. Okay, so there is as such directly no concept of limit here. Okay, now let's say limit x tends to let's complicate this slightly, but effectively it won't be, because this method is very simple, like this, x tends to, it's 2. Okay, so how do you do? Again, put the value of x as 2, so 2 square minus 4 upon 2 plus 3, that's 0 by 5, that's 0. See, you can do direct substitution as long as you get a value. We are getting a value, na? Even if it is coming 0 or if it is coming positive or negative, as long as you are getting a value directly, you can do direct substitution, no problem. Okay. One more simple example here. Limit x tends to 0, square root of 1 plus x minus, no, plus square root of 1 plus 1 minus x upon 1 plus x. Okay, I've made the expression complicated, but limit is x tends to 0, replace x with 0. So square root of 1 plus 0, square root of 1 minus 0. Denominator is there, but 1 plus 0, still denominator is not effectively 0. It is coming 1, so it's not a problem. Root 1 is 1, root 1 is 1, 2. Okay, you got the value, effectively. All right, that's your direct substitution. All right, let's continue with the second type. Okay, that's algebraic or factorization, I'll say, method. You can use factorization also. Now, how does a factorization work? Let's see. Now, limit it is x tends to 2. I'll start with the question that I gave you in the starting, x minus 4 upon x minus 2. Okay. Now, see, you have done direct substitution. So, let's put directly 2 as here. So, 2 square minus 4 upon 2 minus 2. It is coming 0 by 0. That's not defined. We cannot define. Denominator first of all cannot be 0, and this is coming 0 by 0. So, we cannot judge this. So, direct substitution fails here. Okay. The moment direct substitution fails, now you have to start solving limit with some idea. So, right now I have given you a heading as factorization, and you can see this is an algebraic expression. We can easily factorize. So, let's see the alternate solution. Limit x tends to 2. I can do a square minus b square, so it becomes x plus 2, x minus 2 upon x minus 2, x minus 2, x minus 2 cancels. The question remains x tends to 2, x plus 2. Now see for yourself, if you put 2, if you replace this x with 2, you are getting a value which is clearly defined. 2 plus 2, it is 4. That's defined. Here it was coming not defined. Okay. So, your direct substitution can work only in the case you get a answer or you get a defined value. If you are getting not defined, that means you cannot directly apply direct substitution. First, you have to do some idea about that. Right now, so you have learned factorization. So, yes, factorization, and then after solving some part. Okay, and usually see, if you are getting 0 by 0, now there must be some factor which is actually becoming 0. You see, if you put x as 2, this was the expression that was becoming 0, this was the expression which was becoming 0. Because of these two zeros, it was coming 0 by 0, and the moment we cancel these, now the problem is sorted here. Now we don't have this factor, 0 by 0. That's why we were able to do direct substitution. Okay. So, if you are getting 0 by 0, that means there is some common factor in the numerator as well as the denominator. Okay, let's look at one more question. Limit x tends to 2, x square minus 5x plus 6 upon x square minus 4. Okay. So, again, same thing. Use direct substitution if you want. Okay, direct substitution. So, it is coming 2 square minus 5. So, basically, let's solve quickly. 2 square is 4 minus 10 plus 6, okay, upon 4 minus 4. So, it is coming 0 by 0. Again, direct substitution doesn't work. So, we have to do something else. I can see a quadratic, I'll factorize. So, limit x tends to 2. This becomes x minus 2, x minus 3. denominator becomes x plus 2, x minus 2. So you can see these two factors were actually creating 0 by 0. Na? If you put x as 2, 2 minus 2 0, 2 minus 2 0. The moment we cancel this, I think after that you can put x as 2 and it will give you a defined value. X minus 3, x plus 2. Use direct substitution now. So 2 minus 3 minus 1 upon 2 plus 2, 4. Minus 1 by 4. Okay. That's our answer. Okay. Let's see one more. Limit x tends to 1. X cube minus 1 upon x plus x minus 1. Okay. Now for this, again direct substitution. 1 cube is 1 minus 1 upon 1 minus 1, that's 0 by 0. Again it is failing. Okay, so let's do factorization. The numerator is actually a cube minus b cube if you want to look at that. So use the property of a cube minus b cube. What's the property of a cube minus b cube? A minus b, a square plus b square plus ab. Okay. So if we use it here, limit x tends to 1, it is x minus 1, x square plus 1 square 1 minus x upon x minus 1. Again some common factor. You can see in algebraic if we use algebraic identities or we are using the factorization method, always numerator and denominator something is getting cancelled, and usually after that we will be able to put the value of x directly. Direct substitution will work. Okay, use direct substitution now, whether it's working or not. So 1 plus 1 minus 1, it is coming 1. So a defined value, na? What is? I am not concerned with whether it is positive, negative, 0. As long as it is a defined value, it's okay. All right. Let's manipulate it more. Limit x tends to 2, x cube minus 6x square plus 11x minus 6 upon x square minus 6x plus 8. Okay, you can use direct substitution. Okay, it will come 0 by 0, I am telling you, you can check. So direct substitution right now cannot work. So we have to factorize. It's easier to factorize denominator. Let's factorize denominator first. It is becoming middle term splitting, so x minus 2, x minus 4. Okay. Denominator is not a problem. The problem is because of this cubic. How do you factorize a cubic? Now this is a problem. Okay. The method to actually factorize a cubic function is, first of all, consider this as f of x, then calculate f of 1, f of minus 1, f of 2, f of minus 2, any one value. Let's say this one becomes 0. Okay. And so you will say that x plus 1 is a factor, then you divide the function. This is something from grade 9th. You can search it, factorization of cubic. It's a lengthy method effectively, but I'll use one idea that will first of all eliminate this step, then I'll teach you how to divide without actually doing the division. Okay. I'm saying so far what you have done in the above questions, you can see whatever was the limit. If the limit was x tends to 2, you got x minus 2 as a factor. If the limit was x tends to 1, x minus 1 was the factor that cancelled. Again it is coming 0 by 0 and limit is x tending to 2. Can you see yourself that it has to have a factor of x minus 2 in numerator and denominator so that it will cancel? Okay. And you can check yourself also that by putting the value of x as 2, it will become 0. Okay. Now I know already one factor. What you can do is you can literally divide. If you know how to divide a polynomial and you don't want to learn my method, you are free to use your own method like this. This division will take time, so lengthy, it's too short. What I'll do is I'll put like this. First of all, this is x minus 2 na, so whatever factor will come here will have one less power because one x is already here, so it will have x square, it will have x, and then it will have some constant. Okay, now all I have to do is decide which numbers come here. It's like fill in the blanks. Okay, now use your common sense. X cube needs to be generated first of all. How can we generate x cube? By multiplying only these two. Okay, if x cube needs to be generated, it has to be 1. Okay, I've already found one factor. Okay, so this is already 1. I'll do the last one because it's easier. First and last is always the easier one. The middle one is slightly complicated. Last one. See, for this I'll use this one. The constant is coming -6. So we'll, in order to get any term without x, you will multiply the terms without x only. So that means minus 2 will be multiplied with this number and you should get -6. Now use your common sense. -2 multiplied by something is -6. What it has to be? It has to be +3 because 3 into -2 is -6. Only one coefficient, and yes, that is slightly typical. So for that I'll write a few parts, but at least 2 parts you are able to do without writing anything. Okay. What's happening? Okay, it is 3. Okay, this part, for that what we can do is I'll use, you have used x cube, you have used constant 6 also. Now either use x square or use x, your call. I am using x. Okay, again it's not a constraint. X, how will you get x? If you multiply this x with this number, okay, 3 into x, so 3x is already generated, and another x will be generated by what? If you multiply this one with -2, okay, so -2 into something should be equal to 11x. Think for yourself what it should be. (3x) and it is 11x, so it has to be 11, 4, it has to be -4. -4 has to come because now try to, you can recheck also. -4 into -4x into 2 -8x, sorry, +8x, and 3 into x, 3x, so 11x you'll get. Okay, so you'll get here -4. Although it does seem that I'm doing a lot of thinking here, but trust me, once you get used to this method, it's very easy. And if you don't like this method, of course you have the longer method, that is division. Do the actual division. Okay. Who is stopping you here? Okay. Now that I have factorized this, let's factorize it further. X minus 2, this is again this is a quadratic na, so I can factorize it. X square minus 4x na, so x minus 1, x minus 3, and upon x minus 2. Limit x tends to 2. These two cancel, and the moment it cancels, I think the substitution, direct substitution, will be valid. Okay, x minus 1, x minus 3, put the value, direct substitution, 2 minus 1 is 1, 2 minus 3 is minus 1. So you get the limit as oh sorry, one factor I forgot, x minus 4 was also there, no? Upon x minus 4 upon 2 minus 4 is minus 2. So you'll get plus 1 by 2 as your answer. Okay. I'll again repeat how I did the division, but try to see. First of all, use x cube. X cube will be generated by x square multiplied by x. So the number that should come here should be 1, because then only you'll get 1 x cube. Similarly, minus 6 you'll get only by multiplying minus 2 with something. That something has to be plus 3, because plus 3 into minus 2 is minus 6. In order to get the coefficient of x, what did I do? I calculated first of all 3 into x. I have not written here, so I'll show it again. 3 into x, and x will be generated first of all from these two and these two. Okay, this is fill in the blanks. Now we don't know that right now. Okay, so minus 2 into something that we don't know should become 11 plus 11x. So try to think what number should come here. It has to be minus 4, because minus 4 into minus 2 will become plus 8, and plus 3 becomes 11. Okay. All right. That's one way to do this. Or you do by this method, then you'll get this as the quotient. Alright. Next, let's do limit x tends to 2. Okay. Sorry, not 2 this time. Let's do 1 by 2. It is 8x cube minus 16x raised to power 4 minus 1. Again, your call, direct substitution first time, it will become 0 by 0. I know. Okay, you can calculate if you want. Always, first of all, in the exam, you try that before actually solving it. Who knows, you might get a question simple enough on direct substitution. Limit x tends to 1 by 2. Do the factorization. A cube minus b cube is, so this is 2x whole cube minus 1 cube. Denominator is 4x square whole square minus 1 square. So this becomes limit x tends to 1 by 2. A cube minus b cube is 2x minus 1. Then 2x square, so 4x square plus 1 minus 2x, and denominator becomes 4x square minus 1, 4x square plus 1, a plus b, a minus b. Okay, a square minus b square is there, no? It can further be solved like this one, limit x tends to 1 by 2, 2x minus 1 as it is, 4x square plus 1 minus 2x upon this becomes again 2x whole square, so it becomes 2x plus 1, 2x minus 1. Okay, 2x minus 1, 2x minus 1 cancels, and after that direct substitution is valid, so I am doing the substitution directly. So 4 into 1 by 2 square plus 1 minus 2 into 1 by 2 upon denominator is 2 into 1 by 2 plus 1, 4 into 1 by 2 square plus 1. What does the value gives us? 1 plus 1 minus 1 upon 1 plus 1, 1 plus 1. So it is 1 upon 2 to 4. 1 by 4 is the answer for this. Okay. Oh, sorry, I forgot. This was 2x minus 1, so a minus b, a square plus b square plus ab. So plus, 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 so 3 by 4 actually. Plus ab was there, na? Okay. Next question, limit x tends to 1, 2 upon 1 minus x square. plus 1 upon x minus 1. Okay. This time you have two separate functions, 2 minus 1 by 1, 2 upon 1 minus x square, 1 upon x minus 1. Even if you still do direct substitution, you can see 1 minus 1 becomes 0, 1 minus 1 becomes 0. So it is still 0 by 0 problem. So we cannot directly calculate the limit. So what we have to do is limit x tends to 1. Let's do factorization first. This can be written as a square minus b square. So a plus b, a minus b, plus 1 upon x minus 1. Okay. Now what you can do is take these two as common, but you'll say that they are not same. Yes, they are not same, but if you take one more negative, so basically if you multiply both the numerator and denominator by minus 1, it will become 1 plus x. It will become, if you multiply this with negative, the signs will change, and I think after that you can take x minus 1 common. So it is coming limit x tends to 1, 1 upon x minus 1, that's we have taken common, and inside it is minus 2 upon 1 plus x plus 1. Let's solve it now. So limit x tends to 1, 1 upon x minus 1, LCM becomes 1 plus x, minus 2 plus 1 plus x, 1 upon x minus 1, it becomes x minus 1. Oh, interesting. 1 plus x, and the limit is x tends to 1. X minus 1 x minus cancels, and the moment numerator denominator cancel, direct substitution is valid. We can do so, put x as 1, so 1 upon 1 plus 1, 2. Okay. So take common, and remember you can take common from the denominator as well as the numerator. It's not a condition that you can take common from numerator only, not the denominator. It's just that if you take common from the denominators, the factor will also go in denominator. See, I've written here now x minus 1 in the denominator. All right, that pretty much helps you with the factorization, okay, method. All right, so far 2 methods. There are few, I think 3-4 more methods are there, so we'll do that in the next class. For the time being, this is enough for this class. Okay, so revise it, revise the concept, and more importantly revise the algebraic identities. For this factorization method, identities should be very much clear. Okay, a cube minus, I'll tell you which identities are more overly used. So the identities are used are a cube minus b cube, a square minus b square, a raised to power 4 minus b raised to power 4. So this one is, I already told you, a minus b, a square plus b square plus ab. That one everyone knows, a plus b, a minus b. This one can be done in 2 parts, so a square square minus b square. Okay, this is a square square, this is b square square. So because a square minus b square into a square plus b square, which can further be solved as a plus b, a minus b, and a square plus b square. Okay, so plus you need Will term, splitting, and factorization of cubic also. You'll not get power 4 in the exam. Power 4 will take a lot of time, so very less chance. I mean, we have done power 4, but like this, it was a square minus b square, not a proper expression of power 4. Okay. All right, that's it for today. See you in the next class. Good day, everyone. Bye.